Okay, good morning, everyone. Hello. Hope everyone's had a good morning so far. So let me introduce myself. My name is Sohan. I work in Amazon as an Alexa evangelist. So I'm here to talk to you about why I think voice is the next major disruption in computing. We'll also talk about some of the tech that goes behind how these voice interfaces work. And we'll talk a little bit about how designing for voice is different from designing for a screen-based interface. Now, I always like to start off with a small quiz, so I'll ask you a couple of easy questions. Let's hear the answers from you all. Does anyone know the significance of this number? What is 4.54 billion years old? Shout it out. It's an easy one. What's that? Earth. Yes, Earth is correct. This is how old the Earth is. Let's do one more question. Does anyone know the significance of this number? What has been around for 200,000 years? Sorry? Yeah, humans basically. The modern human has been around for 200,000 years. Okay, we'll do one last question. All right, one last question. What is the significance of this number? 100,000 years. Yeah, I heard that correct. So humans have been using voice as a means of communication for about 100,000 years now, right? And it's something that comes naturally to us. It's something that comes spontaneously to us. Even a baby's first words is such a big deal. But if you really look at how we have interacted with tech, it's not really reflected this. So if you sort of graph out how we have interacted with tech so far, this is how it looks, right? And if you see, in the mid-70s was when it all started. We interacted with, that's when personal computers and the era of the personal computer really started. Of course, not everyone could afford it back then. But you had these tiny black and white monitors, and you had keyboards through which you entered text-based commands to get something done. Cut to the mid-80s, and things changed, right? You had companies such as Microsoft and Xerox and Apple come up with graphical user interfaces, right? Operating systems that were visual in nature. And for the first time, it blew everyone's minds back then, but for the first time, you could actually see a file on your system, right? You could see like maybe a text file. You could move this piece of hardware which would translate onto the screen, a computer mouse, right? That didn't exist before. In the mid-90s, things changed again. The paradigm of how we interacted with tech changed. We moved to the era of the web. And to access the web for the first time, you could get information at your fingertips. And this changed everything. And of course, we still use the web. And to access websites and to access portals back then, you had to use early versions of browsers, right? Netscape Navigator, Internet Explorer. And it was so different from using an operating system back then. In the mid-2000s is, I think, something we're all familiar with, where the era of the mobile really came through. Right? And think of the last 15, 20 years or so where the mobile phone has been around. We've gone from really basic phones, with the small screen and a clunky keypad, to the really advanced smartphones that we have in our pockets today. And think of the sort of interactions you have on your smartphone today, right? Something like swipe right, or pull to refresh, or how do you zoom a page on your phone? You do that, like a pinch to zoom. So those sort of interactions didn't exist before. Right? But because there are touch screens and because that's how tech has evolved, we have these interactions now. So if you can see, every 10 years or so, there's been a paradigm shift in how we interact with tech. And sometime in the mid-2010s, there was a shift again, and this time towards voice user interfaces. Right? The ability to talk to a machine and hear an intelligent response. Now, you might ask me, hey, as humans, we've been speaking to one another, we've been using language as a means of communication for so long. Why did it take so long for us to get here? And the simple answer is it wasn't easy, right? But we're finally at the stage where we have access to enough data, we have access to the data processing powers, we have the machine learning in place, we have the AI in place, we have the network capabilities in place. All of this has sort of come together to form this perfect storm for us to be finally able to talk to machines via our voice. We at Amazon, we believe that voice represents the next major disruption in computing. And you'll hear this phrase a lot, especially the ones that probably work in Bangalore with all the startups and things going around. You will hear this word disruption a lot. It's where a new technology or a new platform or a new product, it appears and it changes how we think or changes how we operate. Right? And when it comes to computing, we believe voice is that next major disruption, which means that you will not only be using your voice to communicate with machines in your home, but also in your office, in the supermarket, in your car, at the bank, and everywhere else. Yeah? So in the next few years, we see voice being ubiquitous all over. So at Amazon, we saw this disruption happen. We saw this paradigm shift, and we came up with this beautiful device. It's called the Amazon Echo. I'm guessing a lot of you all have seen the adverts. Or even does anyone own an Echo device here? Hang on. Okay, that's awesome. Yeah, so you guys have obviously operated on the device as well. Essentially, it's a device that lets you voice control your world. And what you really need to know, the main thing about the device is that it has 7 really powerful microphones on the device. Yeah, and because there are 7 really powerful microphones on the device, it enables something called far field recognition, where I can stand like 20 feet away from the device and still communicate with it, and it'll accurately pick out what I'm trying to say. Yeah, so let's take a quick demo.
Good morning. Alexa, what's India's cricket score?
Australia beat India by 50 runs.
Alexa, please add tissues to the shopping list.
I've added tissues.
Very funny.
Introducing Amazon Echo. Sports updates, music and more. Just ask.
Yeah, so as you can see, that was just a small clip, but as you can see, it's a device that lets you voice control your world. Yeah, so if I want to do anything from play music, to get the cricket score, to get the news, to control the smart home devices in my house, all of that I can do just via my voice. All I have to do is just speak to the device and it will get it done. So it's not just us that we're talking about it. I mean, the statistics are there as well. If you really look at it, 2015 was when the Echo was launched, and just take a look at the number of voice searches that have increased. Right, sometime in 2015, the number of voice searches have exponentially increased, and that number is only going to go up more and more. Amazon Echo was the fastest selling Bluetooth speaker in history, and by 2020, it's expected that there'll be 200 billion voice searches, right, which is an insane amount. Also, on a study about digital assistants, it's estimated that at 2020, there'll be 1.83 billion people using a digital assistant via voice, which is a huge number if you really think about it. So a lot of people, I think, still ask me, and they're a little skeptical about this, right? And it's fine, because we're so used to operating on our cell phones. And a lot of people say, hey, I have my cell phone, I'm fairly comfortable with this, do I really need this new device? Let's take a look at few interactions that we do on a day-to-day basis that I think is improved by voice. Right? So let's take about how you would add a reminder on your phone. So typically, the modern way, you would locate your phone, you'd unlock it, you'd open the appropriate app, you'd find the right to-do list, then you'd actually type out the task that you want to remember, and then you'd close your phone and then put away your phone. Right? So these are the 7-8 steps that you need to do something as simple as adding a reminder on your phone. I think the easier, faster, and more natural way is to just say something like, Alexa, add book flight to my to-do list. Yeah, it took me like a couple of seconds to do it, and it's just added, and I can access it at any point of time. Let's take another example, which is turning off the lights in a smart home light. So again, the modern way would involve the same steps, where you locate your phone, you unlock it, you open the appropriate app, you navigate to the bulb of the room you want to turn the light on, you press the turn off light button, and then you exit your app and close your phone. Honestly, I think I just prefer the good old way, where I just walk up to a switch and turn it on or off. Yeah. But again, with voice, I think it's more easier, it's faster, and it seems more natural to just say something like, Alexa, turn off the bedroom light. Yeah, and these are just few interactions that are better or more natural or easier via voice. Similar to how on your phone, when you buy your phone, your phone can do a few things, right? You can make calls, you can send SMSs. What's the first thing that you do? You download apps, right? You'll download a WhatsApp or Facebook and Instagram. Similarly, on Alexa, there is something called a skill. A skill on Alexa is like an app on your phone. And again, very similar to how there is a Play Store and an App Store, there is a skill store that Amazon has as well. So anyone can build a skill, and I'll be doing a workshop later today on how you can build a skill as well. So anyone can build a skill and publish it to the skill store. Currently, we have a ton of skills. We have like 50,000 skills on the skill store. And in India alone, we have 15,000. And we're really looking at developers such as y'all to really build out the skill ecosystem. Just few examples of famous skills that we have here. We have a Savan skill, we have an Ola skill, and a Zomato skill as well. Right? And these are just few examples of the popular Indian startups that have actually built Alexa skills. So people have asked me, and we have a booth outside as well, and people ask me some interesting questions when you're at the booth, right? So someone came and asked me saying, hey, when does this device get outdated? Like, when do I have to buy the next version of this device? And I thought that was an interesting question, because what I said was, theoretically, you don't have to buy the next version of this device. The device is completely cloud-based, and the cloud is where all the improvements are continuously happening, right? Thanks to all the advancements in machine learning and all the AI that's going into the cloud, Alexa is only getting smarter as the day goes on, right? So more access to information, it gathers more information, can recognize more accents, more languages, and so on. So all the improvements are sort of happening on the side of the cloud, which means Alexa is only getting smarter. So I've used the word Alexa a lot, I've used the word Echo a lot, so let me actually just define what they are. When we say Echo, we mean the line of hardware devices, right? There's an Echo, the Echo Dot, etc. And you can see demos on our stall right outside this room. When we say Alexa, we mean the cloud service that really powers these devices. Yeah? And the Alexa cloud service need not power just the Echo bunch of devices. There are a lot of third-party manufacturers as well who have Alexa-powered devices. You can build your own device that is Alexa-powered too. So if you have built a smart device and you say, hey, I want this smart device, maybe it's a toy or something that sits in the car dashboard, and you want it to be voice-enabled, you can put Alexa on that device. So essentially, this Alexa cloud is acting as an endpoint for like millions of devices around the world. Yeah, it's made up of two frameworks. Essentially, the first one is called the Alexa Skills Kit, which is essentially if you want to build an Alexa skill, right? Maybe you have an idea for some content or a game or some productivity skill, you need to use the Alexa Skills Kit. And like I said, if you want to put Alexa onto a hardware device, maybe you're a hardware hacker, you've built a device that you want to be voice-enabled, you can use the Alexa voice service. All right, so I know this is a technical crowd, so I want to tell you how these voice interfaces work and how Alexa actually works. So let's do a deep dive into the tech behind this. Right? How, when I say something like Alexa, what's the weather, how it can accurately give me a response about what the weather is. So this is a typical interaction diagram for a user to talk to an Alexa device. At this point of time, I really want to stress on the fact that most of the magic happens in the cloud. Like I said, when we say Alexa, we mean the cloud service that powers these devices. So the hardware device, they act as input-output, and they do a couple of things, but all the cool stuff happens in the cloud. So let's take a look at what the hardware device actually does first. The hardware device does two things, right? One, it listens to something called a wake word. You would have noticed that most interactions that you saw in the ad, and if any interactions with Alexa start with the word Alexa itself. Yeah? That is called a wake word, where essentially that's when the device knows, okay, now is where I process what the user is saying. It would be very inefficient if the device is processing all data and listening into all conversations, and of course it wouldn't be good for privacy. So until a user says the wake word, the device doesn't process what the user is saying. Yeah? So the wake word is a sort of indication to the device to say, hey, now is when you start processing what I say. Once the user says the wake word, there's a cool piece of hardware tech that actually happens, and it's called beamforming. So essentially, each of these devices have a circular array of 7 microphones, right? It's in a circle, and which means it can detect sound in a 360-degree arc, like all around. So what happens is when someone speaks to Alexa and says, hey, Alexa, what's the weather? The mic closest to the speaker or to the user detects the source of the sound. So if I'm standing here and the device is here, the mic closest to me detects the source of the sound. The other mics sort of auto noise cancel themselves, right? They do noise cancellation, which means that that one mic can accurately pick up what I'm trying to say. So in effect, it's forming a beam towards the user to accurately pick up what I'm trying to say. This is how far-field recognition is actually possible, where you're standing in a room, you're 20 feet away, there's like ambient music playing, and someone across the room says, Alexa, what's the weather? Thanks to beamforming, you're accurately able to pick out what the user is saying. Once the user says anything, though, whatever the user says is pushed to the cloud, which, like I said, where the magic happens. So let's take a look at what happens in the cloud. So fundamentally, the cloud does two things. Right? The first one's called automatic speech recognition, and the second one's called natural language understanding. And obviously, there's a ton of machine learning, like different algorithms that go into each aspect of this, but we'll talk about what speech recognition and natural language understanding is. So speech recognition is essentially converting speech to text. We all know that. It's been done in computer science. But how do you do it accurately and with context? I think that's the key. Right? Especially in a voice user interface, you need to have very, very good speech recognition to be able to understand different accents, different dialects, different ways of saying the same thing. So for example, if someone says the phrase for t times, right? I've broken it down into its phoneme, it's for t times. How do you know if the user meant 40 times, doing something the number 40 times, or if they meant for tea times, reference to chai? maybe the user wanted to play golf. To tee off means to play golf. Or there's a small probability it's 4 people want to play golf. Probably not, but who knows. Right? So how do you accurately know what the user is trying to say? The Alexa cloud uses something called automatic speech recognition, where it can look at the training data that you as a developer provide to accurately match what the user is saying. So you as a developer would have probably built a skill to do with coffee and tea ordering, right? So you have to provide some training data to indicate so. And then Alexa looks at what the user is saying and looks at the training data that you have provided to make that match. So suppose you have built a skill about coffee and tea ordering, there's a good chance Alexa will match it to for tea times, because that's what it matches to the training data that you have provided. So this way, the Alexa cloud is accurately able to get speech to text with some context as well. Once that speech is converted to text, and this is the most important part, how does a machine understand what that means? What does that text mean? Yeah, and like Sandeep said, conversational interfaces are big, right? It's the next big thing. So the fundamental or the underlying sort of principle behind most conversational interfaces is something called natural language understanding, where computers can understand human conversation, right? And how it does so is using these natural language or NLU algorithms, which basically converts human conversation, which is unstructured, into something structured that a computer can understand. Yeah, so when it comes to chatbots and Alexa skills and any conversational interface, NLU is the underlying sort of tech behind it. So let's see how NLU actually works. So this is typically how a user would talk to Alexa, right? They'd say something like, Alexa, ask restaurant finder for breakfast. So there are a few things happening here. Always, like I said, you start with the wake word, which is Alexa. Now, every skill has something called a skill invocation name. Remember, we are in a voice-first world. There is no screen on this device. So how would you start a skill? On your phone, you would physically press the icon of the app, right, to start the app. On web, you would type out the address of the website you want to go to, like you would type out Amazon.com. But in a voice-first world where there's no screen, how do you really start a skill? That's why each skill has something called an invocation name that you have to say out aloud to start it. So in this case, the invocation name is restaurant finder. Or in the case of, I know Sanjeev Kapoor has a great skill, so he has a skill called Sanjeev Kapoor recipes. So you have to say something like, Alexa, open Sanjeev Kapoor recipes. Yeah, so you have to say the invocation name of the skill to start interacting with it. Once the user said that, a user can say something like, Alexa, ask restaurant finder for breakfast. Now the thing with voice user interfaces is, right, there are so many different ways of saying the same thing. Yeah, I can ask for breakfast by saying, ask restaurant finder for breakfast, ask restaurant finder for a good breakfast place, to find places to eat in the morning, for a spot that serves the most important meal of the day. These are just few variations of saying the same thing, which is you want to find a place to eat breakfast. Yeah, and essentially the job of an NLU algorithm, the natural language understanding model, is to match all of these things to something called an intent, right? An intent is, think of it as the intention or the meaning behind what a user says. So you as a developer define an intent, and it's the job of the NLU algorithm to match users' utterances to intents that you have defined. So for instance, anything to do with breakfast and eating in the morning, finding a hotel to eat breakfast will be matched to an intent, like let's call it recommendation intent. All right, so let's take another example. Something as simple as getting the weather. Yeah. So let's say as a developer, you're building a skill to give the weather, and you have one intent, which is a get weather intent, right? Keeping it simple. I think there are so many ways to ask for the weather. You can say something like, hey, what's the weather? Tell me the weather. Get me the weather, please. You can say, is it hot outside? Is it cold outside? Is it raining outside? You can even say something like, do I need a coat today? Do I need a jacket today? Do I need an umbrella today? At the end of the day, these are just different ways of saying the same thing, which is you want the weather. Yeah? And people might be thinking, hey, why do I need this NLU algorithm? I can just write like a string compare or a string lookup saying if there is the word breakfast or weather, I'll just give the weather. But it doesn't quite work that way, right? Because even if you take a look at this example, if you take a look at the last one, there's no mention of the word breakfast, but it still means the same thing. So that's really where natural language understanding algorithms come into picture, where they can match what a user is saying to an intent that the developer has defined, and that is the structured data that you get. So I told you what an utterance is, which is what the user says, and I told you what an intent is. I'm going to tell you what a slot value is. Essentially, a slot is a variable that completes an utterance. When I say variable, I mean anything that can change, any value that can change. So in this case, the value 4 is the variable, right? Because that can easily change to 5, 6, 7. So I can always say, Alexa, open restaurant finder and recommend a restaurant within 8 miles or within 6 miles. So that value that can change within an utterance is called a slot. So in this case, the intent would be the recommendation intent, and the value would be the distance, which is, in this case, 4. So let's take another example. Let's go back to our weather example. When I say something like, what's the weather in Bangalore, what would be the slot value? Y'all tell me. Bangalore, yeah, because that's the variable there, right? Because that can change to what's the weather in Hyderabad, what's the weather in Delhi, etc. Similarly, let's do another example. If I say, help me find a Thai restaurant in Bangalore, what's the slot value? Thai? Only one? Yeah, there are two, because there are two things that can change. You can have a type of cuisine, it can be Thai, Mexican, Italian, and a city in which you want to find a hotel. So that's Bangalore, Delhi, so on. Right? So there are two slot values. So any utterance can have multiple slot values as well. Like in this case, you have both Italian food, which is a cuisine, and you have the word 4, which is a slot, the distance slot. So the intent is the same. You still have a recommendation intent, but your slot value changes. At the end of it, Alexa works on a simple request response model. Right? It's a very simple request response model. You can take a look. There's a JSON request coming into your service. You have to send a JSON response out. It's as simple as that. Yeah? And that request that's coming in is that structured data that I was talking about. What the NLU algorithm does is it takes that human conversation, breaks it down into intents, slots, adds in some metadata, and sends a nice structured JSON to your service. As a developer, all you need is a good JSON, am I right? So in your service, you can do what you want. You can make an API call, you can hit a database, you can hard code some data. It's really up to you. All you have to do is use our SDK to send a structured response back. All right? Remember, the response that you're sending is also a JSON and it's in text. So that text has to be converted to speech. Again, we're in a voice-first world, so that text has to be converted into speech again by the Alexa cloud. Luckily, there's something called SSML, or speech synthesis markup language, which enables this text-to-speech conversion. Right? And I think the great thing about SSML, which by the way is a general technology, it's not Amazon specific, is think of it as HTML for voice. Yeah? There's a big difference between me speaking to you and a computer reading out words. I can change my pitch, I can change my tone, I can talk really softly, I can talk really loudly, I can make these small subtle changes. A computer reading out words can't ideally make these changes, right? Typically it can't. But with SSML, you can add simple markup tags to make these changes to sound more conversational. So for example, if I want to add a pause in a statement, I can just add a simple break time tag and add a pause. Similarly, I can get Alexa, and these are just few examples, but I can get Alexa to pronounce a word, to say HELLO instead of hello. And there are also these things called speech cons, which if you want Alexa to say fun things like matcha or IO, you can get it to do that as well. Right? And these are just small things like local lingo that we've added to make it sound a little more conversational and a little more engaging. So a quick recap of whatever, in case you nodded off in the middle. So if a user says something like, Alexa, is it hot outside? Yeah, few things happen. First, that audio, that signal is processed, and on the device, few things happen. The wake word is detected, a beam is formed, and what the user said is pushed to the cloud. And the cloud is where all the magic happens. Yeah, the first thing is automatic speech recognition, where speech is converted to text. That text, then you have to understand the meaning or the intention behind it, right? And that's where natural language understanding comes into picture. You get the intent and the slot values maybe. All that data goes to your skill, where you can do what you want with it. And at the end of the day, all you have to do is send a structured JSON back, and the Alexa cloud takes care of the text-to-speech as well using SSML, and what you hear from the device is the weather is so-and-so. Right? So all of this awesome tech and science and engineering and math goes into just one sort of conversation between you and a voice user interface. All right? So hope that was interesting. If you want the presentation from today, you can either take this, go sign up here on alexa.design/India check-in. I think that N is cut out, it's check-in. So you have to just give your email ID and we'll send you a bunch of resources to get started. Including our GitHub page, our SDK, and a lot of templates and a lot of skill code is out live. We have SDKs in JavaScript, Java, and Python, so you can get started on building. You can also join us at the workshop in an hour or so. But yeah, I'll just give you a couple of minutes to maybe sign up here. All right, so I'm hoping I've convinced you guys that voice is really the next major disruption in computing. And a lot of you all might be thinking, okay, great, like, I really want to get on this bandwagon. I need to learn something about this. How do I get started? And a lot of people, I do a lot of technical workshops as well. In fact, this week I've been traveling a lot. This is my 4th city this week itself doing like talks and workshops. But essentially, the thing that developers ask me the most is, hey, give me that one tip or give me something important to learn about building for voice. So what I usually tell them is that the tech part is fairly simple, right? I think that's what we're good at. That's where we really shine. And I think that's really something we can pick up very easily. What you really need to pay attention to is the fact that for the first time, you're actually designing for voice. So far, all the interactions with tech that we have had have been on screen-based devices, right? The desktop, laptop, mobile phone, tablet, they're all screen-based devices. So all those designs, all those user interactions that you've had so far, either as a designer or as a user, have been for the screen. So they've been for the eye. With voice user interface, things change a little because you're designing for the ear. Right? And there's a huge difference between designing for the eye versus designing for the ear. If you try and port existing mobile apps or existing web apps onto a voice tech, it really doesn't work. Right? Your backend stuff might remain the same, but the experience is completely different. And so there are a few subtle differences between designing for the eye versus designing for the ear. So keeping that in mind, I'm going to talk about 5 principles of voice design. Right? And I think this is interesting because, like I said, we have never ever earlier designed for the ear. So a lot of these might sound self-explanatory and obvious, but trust me, there's a lot of thought that's gone behind it. So the first principle, your skill should have a clear purpose. And I think this is the most important. When I said that we have gone from web to mobile to voice, at no point did I mention that mobile is going to go away or the web is going to go away. Right? The mobile phone came and we all use smartphones, but that didn't really mean the web is gone. What that means is voice user interfaces will become the primary user interface in the future, but that doesn't mean your screen-based devices will disappear. Yeah? So when you're building a skill, choose that interaction that makes something or makes an interaction either faster or more natural or better via voice. That is the most important thing to remember. Yeah? Just for the sake of it, or if you already have an existing mobile app, again, porting that same experience onto voice just doesn't work. So choose that interaction really well. I gave you a couple of examples of how adding reminders or turning on a smart home device is so much easier via voice. So I think that is a good example. Recently, someone in India had built this great skill to check whether the dog has been fed or not. Right? Very simple. So all you do is something like, Alexa, tell dog feeder I've fed the dog. If you have multiple people in your home, sometimes you don't know if someone else has fed the dog and you don't want to feed the dog twice. Right? So something as simple as that. But it's an interaction that's made so much better via voice. So choose that purpose well. My advice usually is to think in terms of crawl, walk, run, which is before learning to run, you need to learn to walk, and before learning to walk, you need to learn to crawl. Right? So start off with something small, like a very small interaction that you think will improve via voice, and then you can always get feedback and start adding more features to your skill. Okay, second one, your skill should evolve over time. I think this is the most interesting among all the principles because fundamentally, the difference between designing for the ear versus designing for the eye is that the eye expects uniformity. How you operate a user interface is you're teaching yourself or you're training yourself to operate that user interface. If you don't believe me, here's an experiment. Okay, take out your mobile phones. Yeah, take out your phones. Look at the 3 apps that you use the most. Okay, and change the location of those apps where they are on your screen. Just try it out. You will find that the next time you want to use one of those apps, you will automatically go to where it used to be. Yeah, because you have trained yourself for the fact that that app exists there. That's how we learn user interfaces. Again, look at it this way. If you go to, like, say, Amazon.in today, and that search bar was on the right-hand side instead of on the top, and everything was mixed up, you would be really confused. Because you have trained yourself to know that, okay, the search bar is on top, there's a menu here, there are some deals here, etc. That's how we deal, that's how we learn user interfaces on a screen. The eye expects uniformity, the ear expects variety. That's how the human ear has been designed or evolved, whichever you choose to believe, but that's how the human ear expects, right? So your skill should evolve over time. You don't want to have the same content every time because people are going to get annoyed a little later on. So something as simple as instead of saying the words okay, okay, okay repeatedly, you can choose to say, okay, sounds good, thanks, sure. Just throw in some variety there. Or here's another example. Most times when people log on to a skill for the first time, they say, Alexa, open Restaurant Finder. The skill says, hi, I'm Restaurant Finder. I can help you with restaurants. What would you like to do today? Right? But if it's okay to say that maybe the first time, the second time, the third time, but the 50th time the user is using the skill, you don't want to hear the exact same message because people are going to get annoyed. So think of how your skill can really evolve over time. All right, the third one, users can speak naturally to your skill. I think this is also very important and sometimes it gets overlooked a lot. But again, like Sandeep said, so far we've been forcing humans to think like computers. We as humans shouldn't be thinking in terms of radio buttons and drop-down menus and swipe rights. Those are not natural human constructs. But now with the machine learning and the conversational interfaces, we can force computers to think like humans. Right? Which means when I'm interacting with the skill, I want to be able to talk as naturally as possible. Yeah? I don't want to go to an experience that's like IVR. You guys know what IVR is? When you interactive voice response, when you call like customer support and they say press 1 for mobile, press 2 for internet, press 3 for broadband. All this tech has improved so that we can get away from that sort of experience. Right? So try and make sure your users can speak naturally to your skill. That means more effort on voice design on your part, but ultimately that's the experience you guys want. Right? And I'll give you a small example as well. A lot of skills expect users to remember exact phrases and words to operate with them. Right? But that's not what you don't want. You don't want the user's cognitive load to be on how to operate with your skill. Because I can like, for example, tie my shoelaces and have a proper conversation at the same time. So that's how people should be able to operate with your skill. The fourth principle, Alexa should understand most requests. Yeah, and this one I think is related to the first thing that we chose, which was choose your use case very well. Once you've chosen your use case, you should make sure that within that use case, everything is understood. What you need to realize is in GUI, in graphical user interfaces on web and mobile, there's something called a happy path. You can't do too much outside of what the website or the app provides you. Yeah, so if you go to a website, there are a few buttons, there's a search bar, that's pretty much all you can do, right? There's a set path to buy something on Amazon.in, for example. It's not like that on a conversational interface, especially on voice. There are multiple ways of saying the exact same thing, like I showed you. So your skill should be good enough to handle all those requests. Yeah? And there will be times when users over-answer or under-answer. It's really up to your skill to take that in. So for example, if you had a travel skill, right, and the skill says, where do you want to go? I say, I want to go to Goa. When do you want to go? I want to go tomorrow. Okay, here are some tickets. But a lot of times, users, when the skill says, where do you want to go? I'll say something like, I want to go to Goa tomorrow. Right? I've over-answered. I've given an extra piece of information. You don't want to come back and say, when do you want to go again? Because the user has already answered that question. The converse also can happen when, again, the skill says, where do you want to go? And I say something like, I want to leave from Bangalore tonight, where I've actually not answered the question, but I've given some other piece of information. Yeah, and this happens a lot with conversational interfaces. So it's really up to your skill and your voice design to sort of understand all these requests. And lastly, your skill should respond in an appropriate way. Now this means two things. One is that it's meant for a device to be in your home, and it's a fairly communal device, so make sure there's no adult content, no inflammatory content, no copyrighted content on the device. But more importantly, what it means is shield your users from your error handling. If you really think about it, there's no such thing as an error in a conversation. Right? If you were at dinner with your friend and they said something really weird, you wouldn't turn to them and say, error 404. Yeah? You'd say, hey, I'm sorry, what did you mean? Or I didn't get that, or can you repeat that? There will be errors in your skill. Yeah? So shield your users. Don't throw an error 404 to your users, but try and say something like, hey, is this what you meant? I'm still learning. Can I help you with this? This is what I can help you with. So you're making it sound far more natural that way. All right, so those were the 5 principles, and I hope that convinced you that voice is the next major disruption in computing, and I genuinely think that this is a good time, right? Because if you read Gartner's report earlier this year, it said that conversational platforms will drive the next big paradigm shift in how humans interact with the world. And Gartner is always at the forefront of innovation and sort of predicting what the next trend will be, and they're absolutely spot on with this, where, like I said, now computers can think like humans, and we'll be conversing a lot more with machines. I just want to end with this image. I guess you guys have seen this image a lot. It's called the March of Progress, where we have gone from ape to be able to handle tools to mastering machines. And you would have seen this image a lot. I think this is the next phase, right? And I think there's an incredible opportunity here, not just in terms of product, but also as an entrepreneur, an enterprise, as a service provider, as a service, in services as well. I think there's a huge opportunity here, and we are at that forefront, and we have the tools ready, right? So it's just up to us to really take up that challenge. So feel free to reach out to me on email and Twitter. We have a workshop and a booth, so come and interact and meet me there as well. Thank you so much. You've been great. Thank you.